Happy Tuesday.
Happy Tuesday. How's it going? I am Matt with Schematical, and today we are talking about how to master search at scale. And so when I say search, some people are like, oh, search engine, I want to rank on Google. This
Select
isn't that.
star from where, right?
What?
Select star from where? I mean, if you're
Oh,
doing the simplest search, right?
wildcard search.
That
Yeah,
works at scale, right?
no, not at all. Not even. Yeah. No, so if you're building your own search engine, so if you've got and almost every product has some form of search, you want to search for records that were created on your product, it's if you're e-commerce, you want people to be able to discover your products. So there's a lot of intricacies that go into doing this at scale. And as you were pointing out there, yeah, a lot of people do a wild card statement, and that's horribly inefficient. And oh, I forgot my coffee, and by coffee I mean Dr. Pepper here. So it's horribly inefficient. And the example I give in there is think back to like the 1930s, and you go into a library and you were to ask the librarian to say, give me every book that mentions the word dog. And then they'd have to go through and check every word in every book to see if it matches that. It would be extremely inefficient. And so what they did instead is they created indexes, index cards and all that. And they made it so they would, when the book arrived, they would add it to an index of sorts. So you'd have it all indexed by author name, by title, by common things. And you could theoretically have an index for every book that has the word dog. You'd have the author that, or the librarian read through it and put it to the index there. Not sure why you'd want to do that, but you could. So what happens is these indexes, understand, are kept up to date before before the book even hits the shelves. When it first comes in, when the record is created, boom, we create an index. So that's the basics of indexing. So now you might be like, Matt, why don't I just index every single word in every single book? Well, that means
I've
you have
done this before. I've done this
yeah,
before. Once upon a time, for a newspaper website that will remain nameless right now, but the entire thing worked on a massive Lucene index. Now, there was different ways that you could store that index and search that index, but I think we're going to very shortly get into some of the fatal flaws of that strategy as well. So sorry, carry on.
well, that's all right. I mean, eventually you'd have more index cards than pages and books in the library, and that's what happens.
You'd have one index card for essentially every word in the language.
It, pretty much, it would be. I mean, you'd have more. The volume of index cards would massively overshoot the volume of books, basically. And the same thing happens. I've seen it where I've gone in and the client has a terabyte of database records and 2 terabytes of indexes, and it's like this thing becomes rather unwieldy after a while. So you don't want to have that situation. And you modern architecture, you can separate the indexes from the database, which is nice, and you can partition the indexes. So, for example, I could have this isn't completely literal, but I can have hardware that stores all the words that start with A through M on one partition and all the ones that do N through Z on the other. And so that way it's a little bit faster because you know which piece of hardware to go look up that search term by. In reality, you'd spread it out even more. And there's some magic with hashing and balancing. But the idea is that you could theoretically index almost every word and have, their own horizontally scalable hardware that would then say, hey, this is where, these are the books or the records that actually are included in this index there. So it's doable, but complex. In reality,
And dare I say overkill as well, because there are so many filler words. Maybe you have a blacklist for words that you don't do, but you'd have so many filler words that are essentially useless to search on.
So yeah, there's 2 ways to do it. You can index everything, or what I prefer to do is find the most commonly searched words on your search engine. So you can end up with all these misses, and some of them are going to be just gibberish. But if you find a pattern, this is a fairly common search term, and let's create an index for it. And so that's a little bit better way of doing it. In reality, depending on if you're brokering information or if you're brokering products, right now is a very interesting time to be alive, because the brokering information like Facebook, we've talked about this before, do you want everything to be searchable by everywhere? Because an LLM is going to suck it all up and learn from it. But if you're e-commerce and you want to move products, I'd focus on the search terms that actually move product. I would say which searches
80-20
actually
rule. 80-20 rule again and again.
Pareto's law. Yep. And so I focus on doing that instead of indexing everything under the planet, because you want to. There's a couple different ways to measure how this would be. You could say the ROI per search, or the amount of gross sales per search, which is not a great metric. And I just did a post on this, but you could step it up to the amount of net margin per search, which so I'd be prioritizing products with bigger net margins for us. You sell less, make more, it's fine. But then additionally, it's not even per search. That's not even the right metric. It's per dollar spent on infrastructure and engineering hours and upkeep that way. So, you want to prioritize trying to make the biggest net per dollar spent maintaining the search engine on the infrastructure side. So that's a metric I use to try and gauge when I design these systems, at least for e-commerce, to try to maximize that ratio there. That was a mouthful.
Right. So you're going to optimize. If you're an office store, let's say, you're not going to prioritize, let's say, paper clips versus perhaps calendars, because you're going to make significantly more per a calendar. Now, that's not a really good example, but or if you have like items, you're going to push to the top the better sellers with the better margins on it. You're not just going to take the search results as they come back from whatever index you have anyways. You're going to do a secondary sort on those, I would assume.
Yeah, so sorting and all that is a very complex thing as well. But yes, absolutely. I mean, Amazon does it with the products they make the most margins on, clearly, like their in-house brands and things like that, versus some obscure thing there. So, but sorting is a very complex thing as well, and you'd want to make sure you're putting the things that are going to move at the top. I keep saying to my e-commerce clients, they've got 5 minutes while they're sitting on a bus or they're on the toilet or something like that, and you want them to find that product that clicks with them in as few clicks as possible, if you use page navigation. So if they have to scroll, even just a little bit to get to that one that's going to match them, or match their search, then that's, let's make that so it's not possible.
So this is a page rank of sorts, but it's personalized, much like Google or any other search engine is going to give you results based upon your search history. Amazon's good at doing this, but I would imagine most other e-commerce stores are not particularly good at looking at your purchase or browsing history when deciding what to show you when you type something into the search box.
So you're talking about what I call context-aware search: browsing history, search history, previous products bought. The example I use, I'm writing a white paper on this right now, which is puts all the posts I've been doing together. But the example I was talking about was, say you bought a brown leather belt, and it knew that. Well, should it be recommending a nice spiffy pair of brown shoes, maybe a brown leather watch band, to go with it? Like you want to, if you get any type of style, you want to match these type of things. And so we can learn this and use, browsing data from other people and purchasing data from other people to train an algorithm to do this. You could train a classification model. You could use AWS Personalize. In reality, I am highly excited to experiment with vector databases for this, to see, hey, clusters of products. You bought cluster A, and they tend to buy stuff in cluster B. What are the relevant products there? So I think there's a lot of exciting stuff.
This almost sounds like it could be an implicit search versus an explicit search, right? Type brown leather belt in, right? The implicit search is, I'm looking at a brown leather belt. There's going to be other products on that page that you might also buy. That's an implicit search there based upon what you're doing. And that's what I would call that anyways.
And this is I love this feature in Amazon, and I also, as a security-minded person, hate it. But as a consumer, I love it. Is when I buy something on Amazon, I'm almost always looking to see what the complimentary products are. I
Mhm.
recently bought a umbrella for the deck upstairs, and they recommended a cover for it, and I hadn't even thought of that. And I'm like, yeah, if I'm buying an umbrella for up there, I don't, Wisconsin winters are going to tear that thing up.
Mhm.
Here's this giant cover, like it's so that right there makes my life as a consumer a lot easier. So if you can,
And their life as a business more profitable.
yeah, 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 you can move more product, then yeah. Um, so I'm big on that. Like whenever you're doing search, to focus on, like you said, Pareto's law, um, 80/20, and I mean, why not use the technology to make recommendation engines better? And so it's something we're having a lot of fun with. Let's see, other stuff I got on my list here to talk about. Um, we kind of talked about this before, but there's a couple different ways to pre-populate your results, right? You want to know
Mhm.
what the result is for any combinations of letters and numbers you're actually going to service before the user actually types it in. So you could put them in an index. You can cache the results. Now, caching has its own set of problems. Okay, I'm not a huge fan of caching for a specific TTL, time to live. So you make a
Mhm.
search, and I cache it for a week, and then next time if everybody that searches that week gets those exact same results, but those results might be for products that are all sold out now. So now we're in trouble. Another
Well,
thing I've seen is
you need to invalidate your cache as actively as you fill your cache in that context.
exactly, and I mean caching alone is a poor way to get over computational issues as well. So
Intensity,
another
yeah.
a way that I've seen attacks come in from people that wanted to DDoS my clients is that they'll find some obscure searches that not a lot of people are making, so they can make that search, and let's just say the search takes 10 seconds because it's not cached, and it'll be cached for a week, and then they make the search again, and it's faster. What they'll do is they'll get all these searches that aren't being made all that often, and they'll nail you with it
All
after
at
the
once.
TTL. Yep, exactly. When they know the TTL is likely to be expired, 90% of those searches, boom, hit them with all the weird stuff that no one's searching for, and your database melts, and you're in trouble. So
Mhm.
it leaves you open to attack. So I definitely wouldn't recommend that one. The other way to do it, and this is if things don't change that much, is you ever read Confessions of Google Employee Number 59?
Sounds like a really interesting book, but no.
So they talk about when Google first started out, they actually released a version of the index. So you had version 001, 002, 003. And so they would build up the index and just release them, one at a time. And that's a good way to do it in some capacities. You want to add in probably an additional layer after that, the checks for inventory, or trending sales or something like that. But if you just wanted to say, you know, um, to have this kind of index where you could test it underneath the hood, or before you release it and then release it, that's kind of an interesting way to look at it.
That's actually the exact approach that I took going back to that search engine in the newspaper. Was every time a new something got published, I would generate a new index. And since it took some number of seconds, not milliseconds, seconds to initialize a new searcher, there was a pool of searchers that would be connected to index A, and they would do their searches. And then as index B was published, as those searchers would come back, they would say, is the index the same number? Yes. Okay, the searcher would live on. But if the index had incremented, that searcher would die and a new one would be generated to replace it.
And that's one way of doing it. Another advantage to doing the version ones, by the way, you delete the older versions eventually.
Mm.
You keep probably just the previous version so you could roll back in
Yep.
case of catastrophic emergency, but you delete older ones so you don't end up with 2 petabytes worth of indexes on a single box. And then the other thing is you can A/B test the quality of those indexes against each
Mm.
other. Are they behaving the way you want? And you could do it A, B, C, D. You don't have to just do one or the other. But
And,
um I'm a
and we're also
huge
super over. Oh, sorry. Finish your thought. Then I got something else.
I'm a huge fan of A/B testing. I mean, that's basically how we train the recommendation engines, is just an insane amount of micro A/B testing.
Right. And we're massively oversimplifying search. We're just saying you type words into a box.
And that's good clarification. Free text search versus predefined filters. So let's just,
Well, and text search is not the only way you search. You may be searching something that I want something of minimum dimensions or maximum dimensions, minimum price, maximum price, has a feature, doesn't have a feature. So it's not just text. There's a whole
that's what I call predefined filters. So there is a
Mhm.
defined amount of values. I mean, sometimes you've got integers in there that you could have ranges with or something, but for the
Mhm.
most part, like let's just say it's colors. There's a preset
Mhm.
amount of colors, there's a preset amount of product types, there's a preset amount of shoe sizes, there's a preset amount of
Mhm.
shirt sizes, there's a preset amount of. So you just have, for every color you got red is 1, blue is 2, green is 3. Those are infinitely easier to search than free text search. Free text search,
Mhm.
let's just do some math here. Let's just say you had a product page that had 10 filters, and each filter had 10 possible values. Okay, you've got 100 basically combinations of different things you can mess around with on that one, unless you're doing multi-select and things like that. But even with that, let's just say we double it, then it's 1,000. There's only so many combinations there. But let's just say you allow them to enter
Wouldn't
in
that be a
60.
factorial versus just a straight mathematics if you have 10
It's
filters with
it's
10 options?
exponential.
Okay, that's what I mean, factorial, 10 times 9 times 8 times 7, etc. So, yeah.
Okay, yeah. So, but you're right. You're right. But you've got only, well, no. So my example. You only had one color you could select for the shoes, not an
Mm.
infinite amount of them there. But we could, sure, if you're doing that. But either at the same time, okay, you got 64 letters and numbers, and let's just say we even allow a space. That's what 30, 6. Oh my God, to the
26, 36, 37.
yeah. So that's all right. 37. That's 64 to the 37th power. That's a lot of
Mm.
combinations, that people theoretically could enter in. And so if you're trying to allow for all these things, then that, it could make it more complicated. I also strongly suggest autocomplete
Mm.
is help guide the user. So they don't, even if
Mm.
they type in crazy stuff, you're still trying to be like, well, select from these common searches. And
Mm.
ideally they won't make crazy searches all that often. If they pick something that you're not auto suggesting, then that's kind of a wild card there. So, but yeah, free text search versus predefined filters, massively different ball
Mm.
games. Um,
Yeah, because I remember some of my complexities were this was also running across classified ads. So, if you're looking for a vehicle in these classified ads, you want the price to be below something, the miles to be below something, the color to be something, the number of doors to be something.
mhm.
And for this, I used Lucene. So, I mean, it did a lot of the complexity behind the scenes. You would categorize saying, okay, this field is an integer, this field is a float, this field is a string. But then you also get the problems like, what about searching on phrases, not just single words? Um,
And not
that,
just that's, I mean, that's something I've had to build for. And then you've got kind of layers of search. So that's, the way I designed it is that any search that was made would go through a pipeline, right? And so that means that like you'd have your most common searches that we'd have, in a lightning fast kind of vector store. So but let's just say you had 2 words and you mixed them up. Well, then the second stage of that pipeline would cross check the common phrases against, mismatched ones and things like that. So you'd work your way backwards and you'd have the fastest, most commonly used, most effective parts of the pipeline at the top that would handle it first, and you'd work your way back towards the less effective ones. So let's just say you did let's just say you're crazy enough to do a wild card search in there. If you were to hit 100% of searches at the wild card, let's just say it's cost you $100,000 a month or something like that. But if you can, take 50% of those searches away, you can get that down to 50%. So that's why you got stage 1. That's the lightning fast cache and the most doable ones. And your goal is to get it. So the amount of searches that actually make it to the end of that pipeline and hit the wild card, if you're crazy enough to do that, is 1%. And that way you're paying 1% of the hardware cost you would have originally. Now, I'm going to point out there's disk space costs involved as well. So it's not, my math isn't perfect right there, but you get the idea. We drop down the compute cost as small as possible. We partition the disk space so we don't have to have multiple, as many places where we're storing the thing, and you get the cost down to a mere fraction of what it would have been had you just gone, as you said at the very beginning of this thing,
Select
like
star.
asterisk. Yep, you got it. So I'm big on using search pipelines. The other thing is you can A/B test the path through the pipelines. So maybe stage 2 or stage 3 is a vector DB, and you're using model A versus model B, so you can cross check and see which model sells the most and is cost effective. So again, I don't know how to stress enough how much A/B testing is involved in making these things effective.
So you can do it fast, meaning you can do an index or a select star sort of search. But that's going to be really massively computationally expensive.
Yeah.
And this really depends on the scale of your business, right? And the scale of the search, because what you're talking about implementing is going to require a significant amount of upfront preparation and thought. Whereas if you say, give me search tomorrow, you can run the straight text search pretty darn easy.
Easy, but not necessarily fast and not necessarily cheap.
Nor well.
Yeah. So this is another thing we talked about many times in a post that I think went live yesterday, is you can have it fast, you can have it cost effective, or you can have everything, every single word under the sun indexed. You can have any 2 of the 3 of those, but you can't have all 3. And so, but there's ways of getting around that. Again, does it matter if you're an e-commerce store? Does it matter that every single time someone said the word the or cat or something is indexed? Or does it matter that the searches that are moving the most product are lightning fast and dreadfully accurate? That's
so. And if you're running your e-commerce on some sort of WordPress plugin, you're probably not going to get this level of complexity, I'm guessing. I haven't looked at any of the search engines there recently, but the stuff you're talking about is custom build. It's for people that are getting hundreds of thousands of searches a day, maybe even thousands or millions, somewhere in that range.
quite a few. I've got the exact numbers. I don't think I'm supposed to disclose, but quite a few. But yeah, and I mean, it also depends on the custom nature of your search engine. That there's, that you could just do it by alphabet. And that's the other thing. Like, how do you order it? By alphabet, by price? Those are silly ways to order things. So the customization comes into the finding the product that fits the user's needs, and has that context aware search to the best of their ability.
Not just fits the user's needs, but is the best product in the eyes of the business put out there. So there's a balance of both of those things in there.
And is optimized, for that. For that. I mean, you want a win-win. You want your customer to walk away with a big smile on their face, and you want to take that check to the bank and cash it. And the more, we optimize for both. You could go one way or the other, but that creates a tension between their best interest and your best interest. So we also factor in that returns would be another one. Things, how likely is this to get returned, and Amazon's phenomenal at that internally, but that's another factor I would take into account when designing this engine is
and then the breadth of your product offerings also becomes a challenge in implementing this search. If you only sell, t-shirts, it's going to be a lot easier than if you sell t-shirts and boots and shorts and hats and other things, because they all have different types of searching, different sizing metrics, different textures, different colors, different everything. But if it's just one solid colored t-shirts, that's going to be a pretty darn easy search.
Yeah. I mean, yeah. Yep. And there's so many different ways you can do this. You could put a vector DB around every review, and then, and vector index, I guess, all those, and use those to qualify the search there. That would be, it's kind of cutting edge stuff there. I guess I say that it's getting less and less cutting edge, but that you could factor in more fields than are originally there. But my gosh, the expense on those things could get pretty high when you're paying for those high GPUs. So you'd want to use some type of semantic caching or something like that to cache the index of the search term was there. But it's a really exciting time to be in the business of indexing knowledge right now using these new tools, but I always have to do the math. Is this a cool feature, or is this a feature that's actually going to improve our users' lives and increase our bottom line somehow? And so it's possible. I could see there being niche search engines for, those custom built Nike Jordans or whatever that people make. And I could see that being really interesting. And I could see them uploading a photo and using that to find other ones, even search by photos, kind of like Google Images. You upload a photo of this pair of shoes you like or this texture that you want, and then it finds the shoe. And so that could make a lot of money. You just got to make sure it makes sense financially, make sure you got the ROI.
And that's a completely different sort of search than anything we've talked about there either, right? I mean, we've talked about text search. We've talked about searching on numbers, but searching on images, okay, I'll let you thump your vector database again, because that's obviously one of the solutions for that, or potential solution for that.
Yeah, absolutely. And I've used the example before of how that kind of works is I tore my bicep earlier this year, back in March, and the MRI, they could have categorized it. They could have taken that photo and run it through this model. And what happens is it give you a two-dimensional database. So imagine, for those of you listening, that you've got an x-axis and a y-axis. And on the x-axis, you've got torn at the top and not torn at the bottom. So it's kind of a percentage, how much torn it was. Mine was fully torn, damn near fell off. And then it can be torn from the top or the bottom. So that's the other axis. Is it torn from the top or the bottom? And so we feed the photo of mine through the model, and it would assign it an X and a Y score there to say where it thinks it is. And you'd look at the other images that have been already scored by existing doctors, humans, to train that data. And so
they've been categorized. Yep.
Yeah, exactly. So
you got your test data. Yep.
Yeah. And so in the case of search for shoe, you'd want to just query the images that are clustered next to it to find similar shoes. So I upload this pattern as a cheetah print. Then you could say, okay, well, one of the scores is out of it. And they're not just 2 dimensions. They've got thousands of dimensions, 700 dimensions. You can choose what you want. But that would decide, hey, these are all photos that are similar in nature to this clustered up. Here's the shoe. And then we get the metadata from that image saying that belongs to product 1, 2, 3. And then we show them 1, 2, 3. And so that's part of the way we can create these very interesting search results using vector DBs. But I'm not saying vector DBs are.
So what you're saying is, when I type in red shoes into Amazon, it is not nearly as simple as it looks to give me that back. Or, I mean, Amazon's not a good example in this, but any number of retailers, when I type in a color or a size or something, it's not nearly as simple as appears as meets the eye.
I would say the companies that are doing well with their search and moving products aren't just doing it alphabetically. They're getting smarter behind the scenes, and if you do it wrong, it's going to cost you an arm and a leg. So it's a lot of people just throw more money at it. But if you're going to scale up, you're not going to want to just throw money at it. You're going to want to make sure you've got a system to scale. I mean, some of my clients, they started off with 100 products in their garage, and now they've got millions upon millions, and we just keep adding zeros to the number of products we've got in the category there. So have a plan, because if you do take off, you're going to want to know where you're going there. I mean, and if you have trouble with this type of stuff, feel free to reach out to us. I am actually, once I finish this white paper on this, we'll be releasing that, and I will be doing workshops on this type of thing to try and help people like you scale. So that's something you need help with. You know where to reach us at schematical.com. The paper will probably be on schematical.com/free once I'm done with it.
All right. Anything else to say today? Anything else to sign off with? So bring it home, Matt.
I'm going to check to see if there's any comments on the live.
There are not any comments at the moment.
Okay. No. Well, with that said, I'm Matt with Schematical, and good luck scaling your infrastructure.
Have a good day, all. Ciao.